So my name is Heydon. I'm a fellow at CSR. Today I'd like to talk in this session about Bluetooth Low Energy. As somebody's just asked me, is this an in-depth discussion of LE? And my answer was, the last time I did LE training, it was 7.5 hours long. And this is 55 minutes long. So yeah, we can't do 7.5 hours worth of content in 55 minutes. I do apologize for that. If you want more information, I've written a book, go buy the book. And Toby's nodding over there because he's read half of it and left it in the plane. So he had to buy a second copy, which I'm not complaining about. $21 on Kindle. $21 US on Kindle. So yeah, it's great. And if anybody buys the Kindle version, give me a Sharpie and I'll sign the book for you. What we're going to talk about today is Bluetooth Low Energy. So I'm going to answer a few questions. So what is Bluetooth Low Energy? What are its important features? How does it work? What are the next steps? What is it good for today? What else can you do with it? And then I'm going to give a calls to action. So Bluetooth Low Energy, I normally describe this as it's a technology that we started with a clean sheet of paper. The first generation of Bluetooth was built around the cell phone and talking to a headset and talking to a computer. And then the app market came along and cell phones became smart. They had downloadable apps, they had downloadable operating systems, they could be upgraded, and that required a completely different way of looking at how to connect devices. So with Bluetooth 4.0, we effectively have enabled a whole new ecosystem of devices. And I look at it that way. There's things that we can do with Bluetooth Low Energy that would be impossible to do with pretty much any other wireless technology out there. The technology has been designed to work from a coin cell battery. It's been designed to be very short range, very low duty cycles, very, very low power consumption. And for those of you who get confused by branding, it's been branded as Bluetooth Smart, but I'm going to call it low energy throughout this talk because that's where it started many, many years ago now. And it's so ingrained in my brain that it's called low energy that I will call it low energy. So let's do a little comparison between low energy and other wireless technologies out there. So at the top, I've got Bluetooth ACL. So ACL is Bluetooth data over basic rate. Then we've got Bluetooth SCO, which is the audio part for Bluetooth basic rate. Then we've got low energy, some Wi-Fi, Wi-Fi Direct, Zigbee, and so a few competitors. And you'll notice that Bluetooth data does data and audio very well. The SCO does voice very well. So audio in this respect is high quality music. Wi-Fi pretty much does the same, but Wi-Fi has got the bandwidth to do pretty good video. Certainly I stream video with Wi-Fi quite happily at home. Wi-Fi Direct does pretty much the same, and I think Wi-Fi Direct are moving into video as well. Zigbee and ANT, they do state. What I mean by state is small amounts of data that are sent infrequently. So my wife has an ANT foot pod that monitors how she runs. And yeah, it works. It sends a bit of data. It costs more than the Bluetooth equivalents because they don't sell quite as many. But you know, that's a problem they're going to have. But Bluetooth Low Energy is about state. That's pretty much what it does. State is about low bandwidth and low latency data. So let's have a look at a fact sheet. So the range, well, I've measured 150 meters and other companies have confirmed that. So in an open field, or quite frankly, the car park at CSR, we measured 150 meters. Output power is a maximum of 10 dBm or about 10 milliwatts. Most chips won't go that high. You know, a lot of chips will do 0 dBm output or 4 dBm output or minus 4 dBm output. But that 10 milliwatts is about the maximum. Current consumption is about 15 milliamps. And this is not really a specification issue. This is an implementation issue. Because we want to run from coin cell batteries. And coin cell batteries, like lithium-ion batteries, work very well up to about 15 milliamps. If you go past 50 milliamps, if you get to 20, 25, 30, or 40 milliamps, then you start destroying that battery. Those coin cell batteries are designed for things like that. It's called a watch. Youngsters don't wear them, but old people like me do. And they have a little stepper motor that once a second or once every quarter of a second, it just does a little spike of electricity to move that second hand and perhaps the minute hand and perhaps the hour hand just a tiny little bit. That's what low energy does. It takes a tiny little bit of energy to just step a packet to another device and then back again. We've designed low energy around that sort of mode of operation. Latency, in terms of how quickly can I connect, send some data, get that data acknowledged and possibly disconnect, is about 3 milliseconds. Very, very quick. We've got star topology. We've got more than 2 billion devices that we can have connected at any point in time. In all matter of fact, it is an unlimited number of devices that you can have connected. Modulation, we use GFSK in the 2.4 gigahertz band. So this is tried and tested, trusted modulation scheme that classic Bluetooth uses, although we have widened the modulation index. We have great robustness using adaptive frequency hopping and a 24-bit CRC. So the CRC in LE is actually longer than the CRC that we use in basic rate. In basic rate, we just have a 16-bit CRC. And therefore, we can actually detect in LE every single 1, 2, 3, 4, 5, and odd numbers of bit errors throughout the whole packet. So we are a lot more robust than even a basic rate is. The security, we've got 128-bit AES CCM. If anybody wants to know what CCM stands for, then there's a whole great big RFC out there, NIST specifications, special publication 800-108, I think it is, that describes how all of that works. The sleep current, again, this is a implementation-specific issue, but about 1 microamp would be a good number to look at. Some manufacturers are slightly higher, some manufacturers are slightly lower. It's horses for courses. And we've got multiple different modes of operation. So we can broadcast data, we can make connections, we've got event data models, we can read data, we can write data. I've missed something, haven't I? Most data sheets for wireless technologies come along and but one other value on there. Data throughput. I've not mentioned how much data can go through this radio. And that was deliberate, because it doesn't matter. If you're asking how much data can go through this radio, you've chosen the wrong technology. If you're sending a small amount of data infrequently, then LE is exactly the right technology for you to use. If you're sending a megabyte's worth of data and you want to send that very, very quickly, LE is the wrong technology to use. It's much more efficient to use a radio such as basic rate or EDR to send large amounts of data. So while we have a very good radio with low energy, it's not a radio designed for transmitting large amounts of data. It's a radio designed to send small amounts of data. So remember that. So how do we work? Well, basically it's just a selection of different simple components. So we've got a very simple GFSK 1 megabits per second radio. That means that the implementation complexity of the radio is very, very simple. We've got a link layer. In classic Bluetooth, we've got a baseband and a link manager. In LE, we just have a link layer. It's got very, very few protocol elements to it, very small number of formats, few number of states, easy device discovery. So the link layer itself is very, very simple. The attribute protocol and generic attribute profile provide a very simple client-server architecture, an architecture that has been proved for years on the internet. If you think of all the internet web servers out there, they're all client-server based, and they work because of that. We've got a very good security model that starts with AES 128 encryption. So it's industrial strength security. And all of these components have been designed together to be optimized for low complexity, low gate count, low enough power consumption to be powered from one of these lithium ions 1.5 volt coin cell batteries, or from scavenge power. You know, we're playing around in our office with how small a solar power can you use in office lighting to power one of these chips. You know, and it's quite freaky how small you can get these solar panels now. You know, I've got a calculator at home that has a solar panel that is about 4 centimeters by 1 centimeter to power effectively an LCD display and a 4-bit micro probably. And we're looking at solar panels now for LE devices that are significantly smaller than that to work from just indoor lighting. It is phenomenal how low power we can get these devices. In terms of the architecture, it's very simple. At the low layer, we have the physical layer. So the physical layer is the one that does all the magic with 2.4 gigahertz. It transmits packets, it receives packets. The link layer defines the format of those packets. Above that, we have an interface between the host and the controller, which is called the host controller interface. You know, we gave 5 bonus points to the person who came up with that name. Above that, we have the link control and adaptation protocol, which is the same protocol that we use throughout Bluetooth. So we have the same packet format for LE that we have for basic rate, that we have for high speed. Above that, we've got 2 components. There's the security manager and the attribute protocol. And the attribute protocol is the protocol that we use pretty much for everything apart from security. And the attribute protocol exposes a set of attributes. And above that, we have the generic attribute profile that groups those attributes into services and characteristics and descriptors. So effectively, you can think of that as an object-oriented wrapper around a set of flat attributes. And then above that, we have the generic access profile that defines how we do discovery, how we do connectability, how we do bondability. And then finally, above that, we have all the profiles and services. And people who were in my last session or the session before that, where I was talking about applications, profiles, and services. So I'm not going to go into too much detail about that here.